We do have other symbols, different authors have used different symbols. For example, we may find CK92 and over that CK95, and C here is a C series. I am asking the students to check, do you think K is the Cretaceous? Look at the magnetostratigraphic chart and try to work out. Note, Cretaceous word starts with C, but there are some cases when Cretaceous is represented by K also. For example, when we say the KT boundary, this indicates the Cretaceous tertiary boundary. And interestingly, in the magnetostratigraphic chart, immediately above CK92, CK95 is found. That means 93 and 94 are missed. One possibility is that earlier CK93 and CK94 were defined, but then some overlap was found. Therefore, wisely 93 and 94 were deleted. Now, let us look at the division of 5A. If we want to do, if some symbol is there 5A, this A will indicate the topmost one of the division 5. For example, 5E has to be in the bottommost, then 5D, 5C, 5B and 5A. Now, if I want to break this 5A into several parts, again D will be at the oldest, C younger, B is still younger and AA is the youngest. So, if I say which one is younger here, 5 BC and 5 DA, which one is younger? I am asking the students to find out based on this lecture. Now, other symbols, notations we will see. Suppose we write 5 capital A small r. What does this mean? This means reverse polarity part in 5AA. This is 5AA. Now, we can break it into two parts, reverse and normal polarity. The reverse polarity will be given by 5AAR. That means first 5 was defined like 1, 2, 3, 4, 5, and then within that A was defined. A means the topmost one. Within that there are several divisions and the topmost one is the next A, and within 5AA there is a reverse polarity, that is the meaning 5AAR. Similarly, you can define 5ABR, 5ACR and 5ADR. And if I ask you here, arrange them from old to young. I hope by following this lecture you will be able to do. I am asking the students to explain 5B1.R. Suppose we write 5C-2 and 5C-1, what does it mean? It means subcrons 1 and 2 in 5C. Together it defines a subcron, and only 5C can define a cron, and here N is not used. Automatically it means the normal cron. Now, it becomes a problem. Just looking at a number 5C-1, how do I know whether it is a normal cron or a reverse cron? So, in this case we have to look at the magnetostratigraphic chart. It is best to consult the magnetostratigraphic chart. It is not recommended to recollect the entire magnetostratigraphic chart. It is very lengthy, pages after pages it is there in the book, but we need to understand how to read the magnetostratigraphic chart in this way. I repeat, in my exams I will never ask to reproduce pages after pages of the magnetostratigraphic chart and the numbers. Rather, the way I am presenting, this will be my way of questioning in the exam also. This would be easier way to remember. Now, as we looked at the C sequence, there is also an M sequence in magnetostratigraphic column, and try to understand it. First of all, this M indicates Mesozoic. So, on the Mesozoic rocks this sequence was established, but it was not covering the entire of Mesozoic. In fact, it was covering mid Jurassic to early Cretaceous time. Just to recollect, where is that mid Jurassic to early Cretaceous in the sequence? Here is the magnetostratigraphic column, and the M sequence comes over here, mid Jurassic to early Cretaceous. This is the M sequence. Earlier we have discussed the C sequence. You can clearly see that the M sequence is older than the C sequence, or the C sequence is younger than the M sequence. Second important point is that there is a gap between the M sequence and C sequence. We can write here that the M sequence is older than the C sequence, or you can put the sentence in another way, the C sequence is younger than the M sequence. Here is the M sequence and here is the C sequence, but the C sequence also does not cover the entire of Cenozoic. So, let us write this part of the stratigraphic table in detail, and let us try to understand which part of the rock is excluded in the M sequence and in the C sequence. Now, the M sequence has been divided from M0 to M25R. Note, this is 0 as a number, this is not O in the alphabet. R stands for reverse polarity. Also note, we are starting with M0 and not M1. In case of C sequence, from the top to bottom, if we look, C1, C2, C3, this was the situation, whereas here it is M0, M1, M2. Why it is so? Clearly it means that two different scientists have worked on the M sequence and the C sequence, and there is a difference in presentation. Now, looking at some 15-year-old literature, it says only 4 radiometric dates have been used tied up with the M sequence. And if that is the case, then 15 years back the M sequence can be less accurate than the C sequence, and the M sequence has undergone less refinement than the C sequence. These are the statements from 15-year-old book. One has to look at the latest literature and find out the status, how many radiometric dates have been added up, how much refinement the M sequence has undergone. Now, let us look at M0 R is at the top, R for the reverse polarity, below that will be M1, then M2, then M3, then M4 and M5. It will go on from M0 to M25 R, and you can see the variation reverse normal, reverse normal, reverse normal, and the same pattern is maintained. If I write this M0 R over here, subsequent finding found the younger units. Now, since it is here 0, 1, 2, 3, if we go upward, that has to be negative number, and that is what has been written here, M minus 1 R, then M minus 2 R, then M minus 3 R. These were assigned later than this initial presentation. And if we look at the latest M sequence, we find in this way, there are abbreviations which I have not written at the top, there are abbreviations in the middle that also I have not written, just showing a part of it so that the main point can be focused. M1N, below that is M1R, then is M3N. So, what has been missed? M2 is completely missed. Then after M3N below, if we go down, is M3R, and then comes M5N, that means M4 is deleted. So, you do not expect below M5N everywhere a continuous numbering like M5, M6, it will go continuously up to M44. That is not so. Why? Because with subsequent findings and research, some overlaps were removed from the M sequence. The same rock or of the same time was assigned, let us say, Mx and My. Once it is understood, then either of them can be removed, or a part of Mx and part of My are overlapping, then correction is required. So, it is a global collaboration using which the C sequence and the M sequence have been deduced. So, as I said, younger than M0R, we use symbols like M minus 1R, M minus 2R, M minus 3R, etc. one thing we find common between the C sequence and M sequence is that in C sequence C1, C2, C3 etc. the increasing numbers going downward to the older rocks, and the same thing is done for the M sequence M0, M1, M2 etc. the increasing numbers associated with M going for the older rocks. As in the M sequence, so also in the C sequence, not everywhere you can find continuous numbering. You have to look at the latest C sequence whether the numbers are continuous or not. And as I said, this is 0, this is not alphabet. And M0R is proposed GSSP primary marker, and it is used as a 0 kilometer reference. And it is used so in the cent 95 scale, it is a name of M sequence scale. A composite M sequence proposed by the geoscientist is the cent 95 scale. Different ways exist to represent the magnetozones. They can be represented by numbers, by letters and by geographic names. For example, San Pedro location name and then N1, R1, N2 and R2. This means reverse polarity zone R1, over which is the normal polarity zone N1, over this is the reverse polarity zone R2 and over that is the normal polarity zone N2. In this writing there are two normal polarity zones and two reverse polarity zones. Or take the example of Gubbio A minus B plus C minus and D plus. When A, B, C, D are written, it means A is at the bottom, B is over it, then C, then D, then E and then F, G, H in this way. Here the minus sign indicates reverse polarity and plus sign indicates the normal polarity. So, A minus, at least in this writing, A is the bottommost and minus means a reverse polarity zone, over which lies B plus, that means a normal polarity zone, over which lies C minus, that means a reverse polarity zone, over which lies D plus, and in fact here I find D1 plus. It looks like D was first defined and then it was broken into D1, D2 and D3. Now for D1 plus is given, this one, which means it is a normal polarity, then D2 and then minus, this means the reverse polarity, and then D3 plus, which means a normal polarity, over which lies E minus, F1 plus, then F is divided into F1, F2, F3, then G and H. G is minus and H is plus. Now do not confuse with polarity zone labels with oceanic anomaly numbers. However, they may have a common cause and can be time correlative. In fact, it has been done. One way in magnetostratigraphy is to look at the vertical rock column and study from bottom towards top, how the magnetic polarity has changed. And the second approach is to look at the oceanic rocks and their magnetic properties. So, the numbers that are used to represent the magnetostratigraphy in vertical column and those used in oceanic rock column, they may or may not match. And in fact, there are few studies where the numbers have been correlated, what has been assigned for the vertical rock column and what has been done for the oceanic rocks. Let us look at this cartoon. Suppose this is the mid-oceanic ridge and from here the main pulse of eruption is taking place. Now it has been possible by geoscientists to locate the rocks here and identify it as Brunhes normal. Symmetrically away from the Brunhes normal, the Matsuyama reverse zone has been established, and symmetrically away from the Matsuyama reverse, the Gauss normal zone GN has also been established. And this has been followed by the numbering of the oceanic rocks. Now, the boundary between the Brunhes and the Matsuyama, this boundary has been dated from time to time and refinements have been made. For example, in 1963 by potassium argon dating, the date was assigned at 1 million year, but subsequent dating in 1966 by the same potassium argon method found 0.73 million year, and then a dating in 2003, and with time 1963 to 66 to 2003 the dating accuracy keeps increasing, and here the date turns out to be 0.789 million year. This time the dating is AR dating, argon dating, and the age is found to be 0.789 million year. So, from 1963 to 66 the age actually got reduced, refinement happened, and from 1966 to 2003 the age got increased. So, what I have talked regarding this boundary, similar concept can be made over here, the boundary between the Brunhes normal and the Matuyama reverse. We can present the situation in this way. Say this portion is the Brunhes, this is the Matuyama, and then here is the boundary 1 million year found in 1963, but subsequently it was found that this boundary has to be moved over here and it is 0.73 million year, and in between the previous position, this 1 million year, if I project it down here, we can put a boundary here. This is Brunhes, this is Matuyama, this is to be represented by black zone, this is to be represented by white zone, this is black, this is white, but here this becomes a black zone and this remains as the white zone. And in 2003 further revision was made. Now, from if I project this 0.73 million year down here, the boundary between the Brunhes and Matuyama shifted towards the right hand side. As I said, the age is slightly increased. So, here comes the boundary between the Brunhes and the Matuyama, and Brunhes becomes the black zone, then comes a white zone, then comes the black zone, and then here M comes the white zone, and this time the boundary is here between Brunhes and Matuyama and it is 0.789 million year. Let us look at the magnetostratigraphic succession for the Miocene, Pliocene and the Pleistocene time. Magnetic polarity zones have been numbered right from 1 at the top, that means youngest, and over here at the bottom of Miocene as number 5. We are going to focus on the 3 polarity intervals within C23N. Let us look at how the polarity intervals are presented as per this author. Consider C23N. Then this C23N has been divided from bottom to top as C23N dot 2N, C23N dot 1R, and the youngest is C23N dot 1N. This means we have divided C23N into 3 parts. The bottommost part is showing the normal polarity, then in the intermediate part is showing the reverse polarity, and the topmost part is showing the normal polarity. Even though overall C23 is of normal polarity. Now, the Kande and Kent 1992 Cron nomenclature is slightly modified and expanded. Let us consider Cron 3A. Here is Cron 3A. It has been divided into a reverse polarity at the bottom and the normal polarity at the top. So, 3A, C3A has been divided into 3AR at the bottom and 3AN at the top, as is shown here. This 3AR is not divided. Division is further made within 3AN. So, here there is a division. The bottom has been called as 3AN2, 3AN dot 2, and the top has been called as 3AN dot 1, 3AN dot 1. Now, within this 3AN dot 1, further classification has been made into R and N. So, how to represent this? 3AN dot 1 and then dot 1R at the bottom, and at the top is 3AN dot 1 dot 1N. In this way classification has been made. What is the meaning of 3AN dot 1R 0.25? That means we are now talking about this particular magnetostratigraphic unit. Suppose this one is expressed with a bottom and a top, then this is actually representing a horizon within the subchron which is 25% from the base of the subchron. That means if the total length, vertical extent of the rock is 100 unit, then at 25 unit this particular horizon has been represented by 3AN dot 1R within bracket 0.25. So, what it means? The base can be represented as per this nomenclature as 3an dot 1r00, this writing will mean the lower boundary of this subchron, but no one will write like that probably, and the top will be represented by 3an dot 1r then 1.00, 3an dot 1r and then 1.00, this would mean the top. The student needs to remember these two and this one also, so that the concept remains clear. Let us look at another version of the magnetic polarity time scale. This is taken from a 1979 publication, so some changes might have happened further. Brunhes has the Laschamp polarity event, that is a question mark, and Blake polarity event. These are in the top position of the Brunhes. The Jaramillo within the Matsuyama can be seen to be approximately within 0.97 to 0.90 million year back. Once we look at the older Matsuyama examples, the Olduvai comes within 1.87 to 1.67 million year back. Older than Olduvai is a reunion polarity event, that means which is older than 1.87 million year. This is a disputed place. As on 1979, it was not clear whether there was normal polarity or reverse polarity, and here is the caption. Further down within the Gauss, there is Kena and Mammoth polarity events. Within the Gilbert, there is Kochiti, Neunivac, Siduf Gel and Thavera. With time, the refinement in magnetostratigraphic concepts keep on going, and I am going to give you two examples where the old concept gets modified. For example, the oceanic crust in the Pacific older than M29. What does that mean? M29 is here, so below that will be M30, M31, etc. Older than M29 means we are essentially meaning these numbers. They were earlier considered as a Jurassic quiet zone. What is the meaning of this quiet zone? And we see this term used again in the next example. This quiet zone means it is a zone which cannot be correlated, no events, no anomaly. Subsequently, the deep toe profile indicate that this zone actually consists of complex suite of correlative anomalies. There are normal and reverse polarity within it, and they can be correlated from one basin to another. That means it is a global event. Now, this apparent quiet sign was a consequence of, we think, weak intensity of geomagnetic field or high geomagnetic reversal rate, frequently normal to reverse change was taking place, but that blurred these signals, geophysical signals. Having said this, be alert that this toe profile interpretation has got certain assumptions. We will not get into the detail. There is another term, Cretaceous quiet zone, ocean floor that formed from the Aptian to the Santonian. Within this range, that means within the Cretaceous, globally traceable magnetic anomaly was found. So, it is a single uniform event for a significant time, that is why it is called a quiet zone, and within this zone the Earth's polarity was mostly normal. Let us look at few other terminology. Tau.3n indicates polarity chron torsion -3n. What does it mean? It means third major normal polarity chron, upward from the base of the torsion stage. So, such writing can be found. Another way, JK-M, this means Jurassic, Cretaceous time and with mixed signal. Earlier we wrote N and R for normal and reverse polarity, here M is indicating mixed signal. And PCR, such abbreviations can be seen, P for the Permian, C for the Carboniferous, so we call it Permo-Carboniferous, and capital R here indicates the reverse superchron. So, small r was used earlier, and in this case capital R has been used. In this way, different scientists have used different symbols, and in the C sequence and M sequence at present a mixture of symbols can be found. Let us see how we correlate the GPTS with some specific areas magnetostratigraphy. This diagram is a specific example from the Haritaliangarh section, which is located in the Bilaspur district in the state of Himachal Pradesh in India, where the Shivalik rocks are exposed. These rocks consist of vertebrate fossils and few absolute ages of these sections are available. Here we find long and continuous exposures of rocks, which makes it feasible to do the magnetostratigraphic studies. The GPTS from the previous author is plotted along the x-axis, and the finding from this Haritaliangarh section, let us call it HS, is plotted along the y-axis. Section to section correlation has been made in a similar way what has also been done in biostratigraphy. In my NPTEL lecture I have described in detail. So, here GPTS and the HS has been correlated, the points have been plotted, and the best fit line with the correlation coefficient 0.998, which is close to 1, which means a strong correlation, this has been established. Along the y axis also the stratigraphic thickness of the layer has been plotted. Since a few absolute ages were available, we were able to correlate the GPTS. Such correlation in terms of a straight line will be found when the sedimentation rate of the Shivalik rocks, or if it were a extrusive lava deposition, then the extrusion of lava, its rate is nearly constant. Long continuous section is required and many trial correlations are attempted. Successions having a hiatus will not be possible to generate this kind of straight lines, that the GPTS is plotted along the x-axis and the trial section is here, and such a straight line will not come if there is a hiatus within the trial section, which is not the case here. We do not have hiatus in the Haritaliangarh section. If there are frequent polarity switches, very frequent, then such correlation will be problematic or will be difficult to generate. Conversely, if I get a curve of best fit which is not a straight line, then it can indicate a hiatus somewhere present, or it can indicate too many polarity switches. Spurious apparent polarity subcoron may be due to hard secondary magnetization not completely removed by demagnetization techniques. We will see the magnetostratigraphy from the Deccan Trap rocks. We are looking at a part of India map. Some of the important locations: Nagpur, Kundam, Amarkantak, Ellora, Kalsubai. The presence of Deccan Trap is shown by shaded region. There is also exposure of Deccan Trap outside the map in this direction. If one goes, one finds Saurashtra region where significant amount of Deccan Trap is exposed. Let us focus on the Deccan Trap exposures, what is shown within this map. The lithostratigraphy, the chemostratigraphy and the magnetostratigraphy of the Deccan Trap is presented. Lithostratigraphically, there are Kalsubai subgroup, Lonavala subgroup and Y subgroup, which are further divided into several formations. Chemostratigraphic division involves same nomenclature: Kalsubai subgroup, Lonavala subgroup and Y subgroup, and then there are different formations. Not all the time the formation names will match, because they are done by different authors and also by different methodology, lithostratigraphy and chemostratigraphy respectively. In case of magnetostratigraphy, R stands for the reverse polarity and N stands for the normal polarity. So, this is a zone of normal polarity and there is a very long time zone of reverse polarity. Looking at this bar diagram, C30N has been marked within the Deccan Trap rock from 68.2 to 66.4 million year. Then as one goes up, there is C29R, that means the reverse polarity is indicated by the white bar. Here the normal polarity is indicated by the black bar, and again near the top of the succession we get C29N, N for the normal polarity given by the black bar. So, two thinner normal polarity at the top and at the bottom of the Deccan Trap succession are found, and there is a middle thicker reverse polarity covering almost 80% of Deccan lava. Here is a word of caution that there is a chance of personal bias in magnetostratigraphic interpretation from the Deccan trap. There might be a few normal polarity within this zone of 66.4 to 65.7 million year. It may not be possible to look at individual lava flows in the Deccan trap and find out their magnetostratigraphy. For example, if some of the flows were missed within this span 66.4 million year to 65.7 million year, and if there were some normal polarity, then we might have missed the detailed magnetostratigraphy of the area. That is what I am writing here. There might be normal polarity happening within the so-called continuous reverse polarity span. What are the stratigraphic units marking the reverse polarity? Right from the start of the Deccan trap in the bottommost time till this span, almost till the, we can say, middle of the Y is a reverse polarity, and the Mahabaleshwar, the Panhala and the Desur formation belong to the normal polarity. I am requesting students to remember for exam purpose these three names, and they are the formation chemostratigraphically where the normal polarity are found. All other names which is not required in my exam to remember will be in the reverse polarity. So, if some names I am asking in the exam, you can check if these are the names, then they belong to normal polarity, rest of them belong to the reverse polarity.